How to add octal numbers. In this tutorial, we will describe how to add octal numbers. In the terms involved in math operations video, we discussed terms involved in addition. Since we will be adding octal numbers, the operands involved in addition are argin and addin. The results will be the sum. For example, let us add the following. Okay, so with addition, we have the terms involved. We have argin, addin, and sum. For this example, we have the decimal representation. For argin, we have 30,750. For the addin, we have the value 5,250. And our expected sum is 36,000. Towards the right, we have its octal representation. For the value 30,750. Its octal representation is 7, 4, 0, 3, 6. For the addin, its decimal value is 5,250, and its octal representation is towards the right, is 1, 2, 2, 0, 2. Before we begin, let's look at some notes that we have to the top, to the left, the top left. We have the powers of 8. We have 8 to the 0 power is 1. 8 to the first power is 8. 8 to the second power is 64. 8 to the third power is 512. 8 to the fourth power is 4,096. 8 to the fifth power is 32,768. And towards the top right, we show the 8 digits that are in the octal number system. Those values are 0, 1, 2, 3, 4, 5, 6, and 7. So let's compute. So here we have an addition. We want to compute the octal numbers. We got 74036 and 12202. And as we usually do, we always start from the least significant column. In this case, we're going to add 6 and 2. So what we'll do is, let's look a little bit to the right here. We have 6, and when we add 2, we get the value 8. But if we look at the top right, we show the set of octal numbers. It goes from 0 to 7. It does not contain the value 8. So that means we need to convert this value 8 into octal form. And what we do is we say 8 divided by 8. And that goes in one time. And 1 times 8 is 8. And we subtract 8 from 8, and that leaves a value of 0. So what this says is that the value 8 is represented in octal by the value 10. So that means that when we add this, we can only put one digit. We can't put 1 and 0. Only one value or one digit is going to go into this column. So the 1 towards the right is 0. And we carry the 1. So now we look at the next significant column. We have 3 and 1. That adds up to 4. And then the next significant column, we have 0 and 2. That comes out to be the value 2. And then we look to the next significant column. We have 4 and 2. We add that. Its value is 6. And then we look to the next significant column. We have the value 8 again. So we already compute that. We look towards the right here. We just converted 8 into an octal form, and its value is 10. So that's telling us for this column, we add 0 here, and we carry a 1. And when we add 1 to nothing else, we have the value 1. Now let's show that this value 106240 is indeed the value 36,000. Let's look at the digit 0 is in the 0th position, 4 is in the first position, 2 is in the second position, 6 is in the third position, 0 is in the fourth position, and 1 is in the fifth position. So let's compute. Let's see. So we have 1 times 8 to the fifth power, plus we have 0 times 8 to the fourth power, plus we have 6 times 8 to the third power, plus we have 2 times 8 to the second power, plus we have 4 times 8 to the first power, plus we have 0 times 8 to the 0th power. And let's break it down further. So this is saying we have 1 times 8 to the fifth power is 32,768. And then we have 0 times 8 to the fourth power is 4,096. And then we have 6 times 8 to the third power is 512. And then we have 2 times 8 to the second power, which is the value 64. And then we have 4 times 8 to the first power, which is the value 8. And then we have 0 times 8 to the 0th power, which is the value 1. And so this comes out to be 32,768 plus 0. And then we have 512 times 6 equals 3,072. And then we have 2 times 64 is the value 128. And then we have 4 times 8 is 32. And 0 times 1 is 0. And let's see, let's add up. We have 32,768 plus 3,072 plus 128 and plus 32. And it is indeed the value 36,000. And this is what we wanted to show. Next, let us perform another octal addition. This time we will add numbers with a decimal point. Alright, so we're going to do another addition, and this time we have our odd-in, we have our add-in, and sum. For the odd-in in decimal form, we have the value 40,750.25, and we're going to add the add-in. This value would be 5,275.25, and our expected value would be 46,025.50. As we look towards the right, we have for the value 40,750.25. Its octal representation is 1,1,7,4,5,6.2. And for the add-in, the value 5,275.25 0.25 is octal representation is 1, 2, 2, 3, 3.2. The notes at the top left, we have already reviewed those in the previous slide, but there's one additional value that we want to look at. It's 8 to the minus 1 power. Its value is 0.125, and it's going to come in handy when we actually compute the digit behind the decimal point. So let's compute. Just as we did previously, we look at the least significant column. Since we're dealing with a decimal point, we'll go ahead and put this here. Just keep it aligned. So we're going to add 2 plus 2. Its value is 4. And we can see 4 is in the set of octal numbers, so there's nothing else we need to do there. So we go to the next significant column towards the left. And then we add the values 6 and 3. But that produces a value of 9. So 9 we have to convert into octal. So what we do is we take 8 and divide it into 9. We get that one time. And then so 8 times 1 is 8. We subtract 8 from 9, we get 1. So this is saying that the value 9 is represented by the value 1, 1. And so a 1 goes here, and a 1 is carried. So the next significant column towards the left, we have the value 3, 5, and 1. And that also comes out to be the value 9. And we just showed over to the left that we just converted the value 9 into octal form. So that means the value 1 goes here, and a 1 is carried up. So now we look at the next significant column to the left. We have the value 4, 2, and 1. That's the value 7. And as we looked up in the set above, for the octal numbers, the value 7 is in the set, so there's nothing else we need to do. Now we look to the next significant column towards the left. We have the value 7 and 2. We want to add those up, and we get the value 9 again. And we showed that we have to convert 9 because it does not show up in the set of octal numbers. We have to convert 9 to its octal form, and its value is 1, 1. We can't put 1, 1 in one column. We can put the rightmost digit here below, which is the value 1, and carry it up to the next significant column. So the next significant column towards the left, we have adding 1, 1, and 1. We get the value 3. And 3 is already in the set, so there's nothing else we need to do. So we go to the next significant column, and we have the value 1. Now what we want to show is that this value 131711.4 is indeed the value 46,025.50 in decimal. Let's look at the positions of the digits. So 1 is in the 0th position. The second one is in the first position. 7 is in the second position. 1 here is in the third position. 3 is in the fourth position. And 1 is in the fifth position. Now, because we have the decimal point, we have 4 to the right of the decimal point. It would be in position -1. So let's compute. So we have 1 times 8 to the 5th power, plus we have 3 times 8 to the 4th power, plus we have 1 times 8 to the 3rd power, plus we have 7 times 8 to the 2nd power, plus we have 1 times 8 to the 1st power, plus we have 1 times 8 to the 0th power, and plus we have 4 times 8 to the -1 power. All right, let's break it down further. So we have 1 times 8 to the 5th power, and that's represented as 32,768. Plus, we have 3 times 8 to the 4th power is 4,096. And plus we have 1 times 8 to the 3rd power, which is 512. And then we have 7 times 8 to the 2nd power, which is 64. And then we have 1 times 8 to the 1st power, which is 8. And then we have 1 times 8 to the 0th power, which is 1. And then we have a final computation, which is 4 times 8 to the minus 1 power. We indicate it to the top here. 8 to the minus 1 power is 0.125, so we put that here. And let's break it down further. So 1 times 32,768 is 32,768. And then we have 4,096 times 3 is a value of 12,288. And then we have 1 times 512 is 512. And then we have a value of 64 times 7 is 448. And then we have 1 times 8 is the value 8. And then 1 times 1 is 1. And then when we have the value 0.125 times 4, it comes out to be a value of 0.50. Now let's add the final computation. So we have 32,768 plus 12,288 plus 512 plus 448 plus 8 plus 1 plus 0.5. And it indeed come out to be 46,025.50. And this is what we wanted to show. This puts us in a position for my next tutorial where we describe the subtraction of octal numbers. I hope this tutorial was helpful. If you find this tutorial to be helpful, please subscribe to my YouTube channel. Also feel free to join us at the computing sector. There will be more videos and tutorials coming soon. Thanks.